So we're gonna do some like algebra and some calculus to find out, if each part of this is constant or not.
Try to convert.
Now, first what we're gonna do is we're gonna use the divide and conquer method. So at this point right here, it changes. So we're gonna divide that part we're gonna divide this part from the rest of the graph, and we're gonna divide it again.
Let's chunking it up, chunk it.
Grouping it in chunks. So we can say this is A, this is B.
I don't know, bro.
Alright, that's B. We could do it right here too. This could be C. We can chunk this. D, E. Anyways, so this is how we divided and conquered it. Now that's how we divided it. Now we're gonna conquer. So we're gonna use calculus to find the derivative of this linear function right here, A. So what we can do is the linear function is just x. You would have the derivative of it would just be. Should I put the Well, should I put the equation? Anybody have a question about the equation?
Yeah.
Okay. It is x n equals n x to the n minus 1 power. So x has 1 at the exponent and 1 in the coefficient. So you multiply 1 times 1 and we'll multiply 1 times 1.
Just 1.
It'll be 1. And there would be the exponent would be 0. So x times x to 0 power is 0.
It's 1.
It's 1, my bad. So 1 times 1 is 1. So that's just a constant line. So you could leave it at right here as a constant line. Would you like to show us how to do it in algebra, algebraically?
Sure. So like this line right here, it looks like y equals x, and we know that the slope for y equals x is, there's a 1 right here, so it's gonna be 1 over 1. So we know that basically the slope will be 1.
And that's basically it. You just find the derivative just like we did right there.
No.
Okay, for the second one, do for B.
Alright, so you're going to calculate for B now. So this is it's a constant line, which means like this it was only 1. So for a constant line, it's just one number.
Y equals 1.
Well, yeah, y equals a number.
Y equals 1, that's the equation.
Number. Okay, y equals 1. Y equals 1 is this one. So this is just a constant line. It has to be y equals a certain number. So we're gonna make up a number. It doesn't matter what. Doesn't matter. It doesn't matter. So no, actually, it's a constant line. So that the derivative of it is 0. Actually, that's what it is.
What?
So it has to come down here on the.
How do you find that?
I found that because.
Do the equation.
The derivative of a derivative of a derivative is 0 always.
So use the equation to show that.
Oh, that's not true, bro.
Use the equation to show that.
What? What are you talking about?
Use the equation to show that one. It's 0.
No, right? Alright, so
The equation is y equals 1 and find the derivative of that equation.
y equals 1. So that is the equation to what? What's that the equation to?
That's the equation, that's a line. Y equals 1.
Oh, to this?
Yes.
Okay, yeah, you're right.
Find the derivative of that.
Yeah, I agree. Alright, so you have to find the derivative of this. So what you do is the exponent.
It's x to the 0. It's x to the 0.
It's x to the. No, it's not.
It's to the 1.
You have 1, right? And then you do it to the first, and then you subtract the exponent. So, oh yeah, exactly. So you do this, right? And then 1 to the 0 power. It's still 1. What are you talking about? What are you saying?
So
Alright, we can point to this. I'll show you with this. The derivative of constant function is always 0. The derivative of a constant line is 0. So we have to go to 0 on this function because that's what the derivative of this is.
Everybody see that?
Can everybody see that? You understand that, Dave?
I can clearly see.
Okay, just making it short.
it's the same principle like algebraically. Like, so it's a horizontal line, right? So you can see her like, whenever there's a horizontal line and like on a PT graph you can see it. Whenever you take the like the derivative or the slope of it, then it'll drop down to 0. So, yeah.
Okay, so for C, we have a little bump right here. So what we could do is actually we could separate that, take that out. We make that C so that we could break this up into, so this part could be x squared, and we could find the derivative of that, and it would be 2x. So to find that, we could do 2x squared, or x squared. X squared, you find the derivative of that, it would be 2x. So then you would, 2x is the linear function, so you come up again on the VT graph. And that would be this derivative would be the slope of that linear function right there on the VT graph. And this is now D.
So like algebraic.
Let me keep going.
I can do it like, so like see, like you see it kind of like parabolic, like right there, cause like curves a little bit. So you can like see like on the graph, whenever there's a parabola and we take the slope of it, it's going to be a diagonal line and it's going to turn linear. Yeah.
All right. Next we have to conquer is part D of this graph. So as you can see, part D is a linear function again. So as we did up here, it's just x. So then we do the derivative of that, and it'll be a constant line. So I'm not gonna show that. We already did that earlier. It's just a constant line at 1. Okay. Now this is the tricky part. E is a negative parabola. It's a parabola pointing down now. So now everything got crazy. It was just, before it was positive, now it was upside down and it's negative. Like, what's up? Rabbit? What's wrong with it? Move it over.
It's fine, it's fine.
Very good. Yep. Good point. Good point.
Okay, so since it's a negative, it's an upside down parabola, we can say that is negative x squared. Since that is negative x squared, it's a negative x squared because it's not pointing up like a regular graph, like a regular x squared would. That's a regular x squared. So since we do this is x squared, this is x squared. So negative x squared would be, I don't know,
Conking down.
like a upside down parabola. So we have to find a derivative of negative x squared. The derivative of negative x squared is you multiply the exponent times the coefficient, so that's negative 2x, and you subtract by 1. Subtract the exponent by 1, so you get negative squared, negative x to the first. And then that would be a downwards line because negative 2x is a negative diagonal line. So you would come down here.
Yes, across the reference point.
Okay, damn.
Good.
Make it like
Very good. Very good. Very good.
And we have to cross the reference point because it's going
Change direction, right?
changing direction. It's going from positive to negative. And when you go from forward to back, you always pass the reference point because that's just when you're going forward. When you come from a positive direction and you go negative, you always go past the reference point because you start positive and you end up negative. You see how I did that? Like that, right?
So like, it's the same thing like before with like part C. The only difference is that like the parabola looks like this instead of this. So likewise, and it's gonna be like linear, but because it's negative, it's gonna be going downward. And again, because it passes like the reference point, then it's gonna go past 0.
Okay. Now for our last section, which is probably one of these. It's just like one of the easy ones. It's a linear function going negative, going to the bottom. So it's gonna stay under the line because under this is at 0, that equals 0. So we're gonna stay under this line, and we're gonna just keep going. Just gonna keep it a constant line as long as we stay under 0, because this is a negative linear function. So when you find the derivative of it, it's gonna be a negative constant line, and when it's a negative constant line, it's gonna stay under 0 because negatives are left of 0, which is under 0, and that's the VT graph. That's how we make a DT graph into a VT graph.
Same thing as before. Again, because it's diagonal, it's gonna turn to a horizontal, as you can see right here. But because it's negative, and instead of it being
Positive slope.
yeah, instead of it being positive, it's gonna be underwards right here and be negative, as shown right there.
So that's how you make a DC graph into a VT graph, and to make an AT graph is easier than making a DC graph to a VT graph, according to Mr. Berry, my teacher who loves us so much. Basically, what we have to do is just to find the derivative again. So you got to find the derivative 2 times. So we have to find every derivative that we found. We have to do it again. So
the graphs would be the same?
no, it's not going to be the same. We have to do the derivative again. So the derivative of what we did. So we have to find the derivative of this, and then we did this earlier. We did a straight line before earlier. So since it's a straight line, it's going to be 0. We can say this was y equals 1. The derivative of 1 would be 0.
Kind of like right here.
Alright. And to find the derivative of 0, you would get 0.
When your derivative is when your first derivative is 0, then your second derivative is always gonna be 0.
We're going to find the derivative of our slope, which was 2x. So it'll just be 2. So we will go up.
How exactly did you get to it, sir?
Because we found the derivative of this first, and it was 2x. So when we do find the derivative of that, we get you multiply the exponent, right? Multiply the exponent times the constant coefficient. That'd be 2, and then x to the first would just be x to the 0 power would just be 1. So 2 times 1 equals 2. Everybody agree? Right? So then you would find that would be the constant. The constant right here would be 2. So the slope of this would just be 2.